Hey guys, welcome to lesson 9.1.4 called Choosing a Strategy. Before we get started, I want to take the time to thank you, those of you who've done the check-in survey that I have, just to kind of check in on you and how you're doing. I did have one specific question about what you thought about this new math schedule, notes one day and work the next. And it seems like most of you like this, and so let's get started with today's notes. The intro says, you now have, I can't read. Oh my gosh. You now have more than one algebraic method to solve quadratic equations using a zero product property, using the quadratic formula, and completing the square. How can you decide which strategy is best to try first? By the end of this lesson, you should have some strategies to help you determine which method to try first when solving a quadratic equation. Okay, 9-34. Examine the quadratic equations below. For each equation, decide which strategy is best to try first. Solve the equation. If your first strategy does not work, switch to the other strategy, and then last but not least, check your solutions. So just by looking at part A, should I factor and use a zero product property? Should I use the quadratic formula? Or should I complete the square? This looks like a good candidate for the quadratic formula because this equation is in standard form, and I want to remind you that standard form is when we have ax squared plus bx plus c, where a, b, and c can be any number. But I have a good feeling that if I factor this quadratic, I'm going to get some nice factors. So let's try it. If it doesn't work, if it's not factorable, I can always use the quadratic formula. So as a reminder, when you factor, draw a generic rectangle and a diamond, x squared down here, constant term up here, multiply those two to get the top of the diamond, put this x term on the bottom. What multiplies to 27 and adds to 12? That would be 9 and 3. See, I told you, some nice numbers. So now I can rewrite this sum as a product of the length and the width. Length, width, equal to 0. And now the zero product property, ZPP for short, tells us that when we're multiplying two factors to get 0, well, one of those factors has to be 0. So take this, x plus 3, and set it equal to 0. Take this other factor, also set it equal to 0. Now you have two linear equations that you can solve for x, okay? If I subtract 3 from both sides here, I get x equals -3. If I subtract 9 from both sides here, I get x is equal to -9, and that's it. Okay? I have solved for x. Again, if ZPP had not worked, then I could just go back and try the quadratic formula or try completing the square. Okay, last but not least, we need to check our solution. Let's do it just for part A so you know how to, in case you don't. Take your original equation and plug your solutions in. So here, plug in -3 for x, okay, for both x's, and then just make sure that both sides of the equation are the same. Here, -3 squared is 9, plus 12 times -3 is -36, plus 27. 9 plus -36 is -27. And -27 plus 27 is 0. So I have 0 equals 0. That works out. That solution works. Okay, let's plug in -9 now for x. So again, I'm taking my original equation and I'm plugging in -9 where x goes, just to check that this works. -9 squared is positive 81. 12 times -9 is something I have to calculate. That's negative 108 plus 27. Again, I get negative 27 plus 27. That is 0 equals 0. So since 0 is equal to 0, this solution works. Okay. We won't do this for all of the problems, but I did want to do it for part A just so you know how to check your solution. All right, we're good. Let me draw a line just separating part A from part B. For part B, I've got a problem. I need to have an equation that is set equal to 0, so let's subtract this 6 over. Now I have 0.5 x squared plus 9x minus 8.8 equals 0. Okay, I don't think that I can use the zero product property here. I don't think that this is going to factor nicely. And more than that, I don't think I want to complete the square either. So here, let's use a quadratic formula. Before I write out the formula, let's identify A, B, and C in our equation. Okay, now that this is written in standard form, A is 0.5, B is 9, and C is negative 8.8. Here's the formula. I'm going to sing it for you. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's plug our values in. This was a 9. And again, I like to put parentheses around values when I plug them in. So I erased too much. Okay, 0.5, 0.5, and then last but not least, negative 8.8. All right, let's simplify. Negative 9 plus or minus the square root of 9 squared is 81 minus 4 times 0.5 is 2, and 2 times negative 8.8 is negative 17.6. And then on the bottom, 2 times 0.5 is just 1. And anything divided by 1 is just itself. And so if I'm dividing this entire top part by this 1 right here, why don't I just get rid of that 1? Okay. Okay, so let's keep simplifying. Oh, highlighter still. I need a pen. Negative 9 plus or minus this double negative turns into addition. 81 plus 17.6 is 98.6. This right here would be my answer in exact form. So I could stop, but I won't. Let's keep going. Let's find the answer in approximate decimal form. That means that we need to calculate what the square root of 98.6 is. And that is about 9.9 if you round to the nearest tenths place. So that gives us, on the one hand, -9 plus 9.9, or -9 minus 9.9. Here, this would be 0.9, and this would be -18.9. Oh, what happened? I don't think the screen likes me writing next to the edge. Dang it. Okay. Can you see that? -18.9. Sorry, I don't have any more room. So x equals 0.9 or x equals -18.9. And this is an approximate decimal form. I don't want to check my answer. I should. I really should. I don't want to show you guys any bad habits, but I think you get the point. Okay, part C. Part C is in factored form. If you have something that is in factored form, meaning that it's written as a product, okay, something times something else, in this case, the length times the width of a generic rectangle, then we can just go ahead and use the zero product property. It's set up for that. Take 3x plus 4 and set it equal to 0. Take 2x minus 1, set that equal to 0, and solve for x. Here, if I subtract 4 from both sides and then divide by 3, I'm going to get x is equal to -4/3. And if I solve for x here, if I add 1 to both sides and then divide by 2, I'm going to get x equals 1/2. Okay, so here I used the zero product property, and look at that. I solved in just a few steps. For part D, first of all, this isn't set equal to 0, so let's rewrite this equation. Let's add the 4 over. And now let's subtract the 8x over. You could have done that in one step, but I don't know. Okay, actually this would be a very nice quadratic to factor using the zero product property. I don't know if you can tell, but that's my favorite method so far. Let's use it. Zero product property. This is actually a special case. It's a perfect square, but in case you're not very familiar with the shortcuts, let's factor this out like we normally do. So x squared here, 16 here, 16x squared on the top, -8x on the bottom. What multiplies to 16 and adds to -8? Well, that would be -4 and -4. Okay, find the length and the width here. X minus 4, x minus 4. So we can now rewrite this. Let me choose a different color so you can see it. We can write this sum as a product, okay? X minus 4. If you wrote x minus 4 times x minus 4 equals 0 instead of x minus 4 squared, that's fine. But since you have the same factor twice, you only need to set the factor equal to 0 just one time. So just take this x minus 4. I've been circling, so let me circle it. Take this and set it equal to 0 and solve for x. Here, if you add 4 to both sides, you're going to get x is equal to 4, and that's it. Sometimes I just get one solution. What does that mean on a graph? That means that if you were to graph this, it would just cross the x-axis one time. Okay, moving on, we've got two more. Again, this is in standard form. Well, almost. This 5 is out of order. But when I have equations in standard form, I can maybe factor. I can already tell this is not going to be factorable. I'll show you why not. If you draw your rectangle and your diamond and you put x squared here and this 5 here and this x term down here, no two whole numbers multiply to 5 and add to -2. So here ZPP does not work. We could always use the quadratic formula, but you know what we haven't done yet? We have not completed the square, so let me remind you what that is again. We take the constant term and we subtract it over to the other side. So now I have x squared minus 2x equals -5. And I need to complete the square, which means that I need to draw a square and figure out what that last term needs to be. So draw a square, a generic square. Put your x squared term in the lower left corner. Take this x term and split it in half. Half of -2x is just -x. Okay, -x plus -x is -2x. Now find the length and width of this square, x minus 1, x minus 1. I hope that you agree it's a square, okay, because we have the same length and the same width. So now what term goes here? What do I need to add here in my square and here in my equation to complete the square? Well, -1 times -1 is +1, okay? So if I'm adding 1 to complete the square, then I'm going to do that in my equation. And whatever I do to the left side of the equation, I have to do to the right side. Okay, don't forget that. So let's simplify the right side of the equation first. -5 plus 1 is -4. Now let's rewrite this sum as a product. Okay. Again, I'm completing the square. I have the same length and the same width. X minus 1. X minus 1, so that's what's going to go here. And now I can solve for x. Okay. To undo this exponent, this 2, I can take the square root of both sides. But there's a problem. I cannot take the square root of a negative number. And so what we have here is we have no solution. I can't solve this for x. What does this mean for the parabola of x squared minus 2x plus 5? I mean, I could still graph it, but what this means is that this parabola will never cross the x-axis, okay? In this example that I just drew, this parabola never crosses the x-axis, which means it doesn't have any x-intercepts and hence no solutions for x when we try to solve algebraically. Okay, one more. Let me rewrite this first and foremost. So let's do minus 2x from both sides, 20x squared minus 32, x equals 45. And then let's subtract 45 from both sides. I mean, I could stop here and then use completing the square, but actually this won't work out nicely, so let's keep going. Let's subtract 45 from both sides. Minus 45 equals 0. Usually when we have big numbers, we can factor out a common factor, but in this case, there's no common factor. So I can't do anything there. So then the question is, could I use a zero product property? Do I use the quadratic formula? I don't really want to complete the square. I think let's just use the quadratic formula. I mean, anytime you have an equation that is in standard form, again, standard form is this. Anytime you have an equation in standard form, the quadratic formula will never fail you. I've been using other methods because sometimes they're more convenient, but in this case, I think the quadratic formula would be the most convenient. So here, A is equal to 20. B is equal to negative 32, and C is equal to 45. Here's a song for you. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm glad I'm recording this right now that my boyfriend who I live with is at work because he absolutely hates that song. Maybe some of you do too, but anyway. Here we plug this in. 20 here, 20 there. And simplify. X is equal to positive 32. Why positive? Because we've got a double negative. Plus or minus the square root of 32 squared. You know what? You know what we'll do this time? We'll plug this entire thing into the calculator. So in my calculator, I'm going to plug this as a whole. Why did I pick this color? You can't even see the green. I'm going to plug this entire thing. So you can't see this, but on my calculator at home, I'm plugging in the square root of parentheses negative 32 close parentheses squared minus 4 parentheses 20 parentheses 45 enter. Ooh, error. Okay. Let's see why there is an error. Let's just calculate what goes underneath. So let me just put this in the calculator. So I'm putting negative 32 squared minus 4 times 20 times 45. Oh, it's a negative. That's why. That's what I was predicting. Okay. Over 40. And as we saw from part E, you cannot take the square root of a negative number. And so part F is also no solution. And we're done. Okay, let me write down the method that we used here, the quadratic formula. Why can I not write this A? Okay. I really can't write close to the edge of the screen, and I don't know why. There we go. Quadratic formula. And I didn't write it here either. Completing the square. Sorry guys, it's Monday. It's one of those Mondays. Okay. Are we good? I think we're good. We used the zero. we use the zero product property in parts A, C, and D. We use the quadratic formula for B and F, and then we did completing the square for part E. So hopefully now you have some strategies for when to choose what method. If it's nice and factored like it was here in part C, you want to use the zero product property. If you think it's going to be a nice factorable quadratic, use EPP. If you've got something like this in part E where you have just a single x squared term and you've got an even x term, you can complete the square. And for all other cases, quadratic formula will always work. Okay, one more problem. 9-36. While solving x minus 5 times x plus 2 equals -6, Kyle decided that x must equal 5 or -2. Not so fast, exclaimed Stanton. The product does not equal 0. We need to change the equation first. What is Stanton talking about? Well, this -6 is in the way. I need my equation to be equal to 0. So what is Stanton talking about? This needs to be 0. We need to have a 0 where the -6 is. So part B says, how can the equation be rewritten? Discuss this with your team. No team here. It's kind of sad, sorry. Use your algebraic tools to rewrite the equation so that it can be solved. Okay, we can do that. Let's multiply x minus 5 times x plus 2 so that we can then add the 6 over. Here's what I mean. I like to use generic rectangles to multiply products. If you prefer the distributive property, that's fine. But when I multiply two binomials, I like to use the generic rectangle. My length is my width. Let's multiply x squared here. 2 times x is 2x. -5 times x is -5x. And 2 times -5 is -10. So then I take all of this and I add it together and I rewrite it here. So I have x squared. Let's combine the 2x and the -5x to get -3x, and then -10 equals -6. Now, because we have a constant term here, we can add 6 to both sides so that I do have an equation that's set equal to 0. Now I have x squared minus 3x minus 4 equals 0. Okay, part C says use the resulting equation from part B for x. So take this highlighted equation and solve for x. This is in standard form, so perfect candidate for the quadratic formula. We could also use completing the square, but we have an odd x term, and so we maybe don't want to complete the square. That gets a little trickier. Or I can factor. I think we've had the most practice overall with factoring and using the zero product property, so let's practice the quadratic formula. We know we love that one. So here's the song. Oh wait, no. First, let's figure out what A, B, and C are. So here, since we just have x squared, and x squared is equal to 1x squared, A is 1, B is -3, and C is -4. Here's the song. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we can plug some terms in. Again, be careful, especially when you're plugging in negatives, you do need the parentheses. In this case, we have a negative already up front and a negative inside. So it's good to have parentheses so we can keep track of our values and of our signs. Okay. This negative turns into a positive. So positive 3 plus or minus. I'm going to put this entire thing in my calculator. If you're going to plug in like I'm doing, make sure that you keep the parentheses and you keep the signs. So what you can't see is that on my own calculator, I'm doing the square root of parentheses negative 3 squared minus 4 parentheses 1 parentheses negative 4. Okay, close that. And this entire thing that I highlighted, okay, this whole thing, square root included, is equal to 5. And then 2 times 1 on the bottom, that's just 2. I know you're getting kind of tired, so I just calculated all of that behind the scenes. Okay, now we have x equals 3 plus 5 over 2 and 3 minus 5 over 2, and that's because of that plus minus thing that we have going on. Okay, 3 plus 5 is 8. 8 over 2 is 4. 3 minus 5 is negative 2. Negative 2 over 2 is negative 1. Okay, this is an exact form because we did not have to use a decimal to approximate any non-nice square roots. Okay, so those are my 2 solutions. Last but not least, part D says use the graph and table of y equals x minus 5 times x plus 2 on your graphing calculator to check your solution. See whether Kyle's solution matches the solution in part C. So Kyle, he forgot, I want to remind you, he forgot that the solution was 5 or negative 2 because he was already kind of doing some math in his head and doing the zero product property, but we said not so fast. There was a negative 6 here. That changes our answer. So let's see. And we're going to see that the answer is no. Let's see if 5 and negative 2 are actually solutions. I did graph this quadratic. If you graph y equals x minus 5 times x plus 2, your solutions are negative 2 and 5, but that's not what we had, okay? Our solutions were 4 and negative 1, the correct solutions, okay? Correct solutions. Okay, and that is all for this video. Email me if you have any questions, and enjoy the rest of your day. I'm having trouble stopping this. Okay.